Hello, this is the solution to number 27 of chapter 3, problem number 27 in the back of college physics. So we have a ball that is thrown horizontally from a 20-meter high building with a speed of 5 meters per second. So the first thing you want to do is draw a picture, and include the information that you've been given so far. So first off, we know that we have a 20-meter high building. And we know that it left with a vertical or horizontal speed, v sub x, of 5.0 meters per second. And we know that gravity is going to be affecting it, pulling it down. And that's going to give us a trajectory that looks something like that. You can even draw an arrow. This is G acting on it. All right, so the first thing they want us to do is to think through the different types of graphs. And this is to point out that the horizontal and the vertical are separate situations, basically can be treated as separate situations. So the first one, B, is asking us to draw the velocity in the horizontal. Well, we're assuming in this case that there's no air resistance, so that is going to stay at a constant, a constant 5 meters per second right there. So that's our 5 meters per second. It's positive. And then when we look at the y-axis and what's happening in the y, as it goes down, gravity is affecting it, and it means it's going to be speeding up, but in the downward direction. So one thing I did forget to put here was, of course, our sign convention. And that would be plus and plus, arrow, arrow. And that indicates to us that the velocity in the horizontal is going to start out at 0, and then it's going to increase. So draw a straight line just like that. Bam. Okay. So now we see that the velocity in the horizontal, the x-axis, is not changing. It's 5 meters per second the entire time until it hits the ground. Whereas as it's falling, as if it were just falling straight down, it's of course accelerating due to gravity. And then that gives us the graph we see at C. For D, now we want to figure out how far from the building, basically, is it going to land. So that's a delta x. All right. So in order to find that, we're going to use the equation. Actually, we've got to find two things. First, we've got to figure out how long it's going to be in the air. If we figure out how long it's in the air, then we can figure out how long that's going to be the same amount of time where it's traveling horizontally at 5 meters per second. The limitation here is going to be how high it is. So the higher it is, the longer it's going to be falling, which is the longer it's going to be moving rightward at 5 meters per second. So we use one of our geometric equations. We'll start out with delta y equals 1/2 g t squared plus v naught. And be careful, this is in the y direction. Also multiplied by t. Since we know that the velocity is not changing in the horizontal, or the initial velocity in the vertical, is 0, we can cancel that out. And that leaves us with this equation, which we're going to reorganize and solve for t, right? So we know how high up the building is, 20 meters. We know that gravity is negative 9.81, and we're looking for time. So we rearrange the equation using our algebra. I'll skip all the detailed steps, but it comes out to t equals 2 times delta y divided by g, all under a radical. And that's going to get you, spelling it out, 20 times negative 20 meters per second. Notice that that's negative because it's going downward. And that's going to help us out because our acceleration is also in the downward direction, also negative. Those two negatives are going to cancel out, so we don't have any imaginary numbers, and we're going to get 2 seconds as our time. So that means that the ball or object is going to be falling for 2 seconds. It's also going to be moving rightward for 2 seconds at that speed given to us at Vx. So now, just to figure out how far away it's going to move, we have delta x, and that's going to equal 1/2 a in the x direction, t squared, plus v naught in the x direction times t. And again, we think through, and we realize that in the horizontal direction, assuming that there is no acceleration, no drag, there's no acceleration, and that leaves us with a simple equation, delta x equals v naught in the x direction times t, which we can further organize, substitute in. We have the 5 meters per second that we calculated, or we got from the beginning, and we now know that it's going to be going in that speed, that direction, for 2 seconds. And that gets us a total distance of 10 meters. Seconds cancel out. So we end up with meters. So then this is going to fall 10 meters away from the base of the building. And this concludes the solution to number 27.